Hello friends, in this video we are going to discuss about solving linear equations using Python. So first of all, linear algebra module which is inside Numpy library will be very helpful for solving this type of linear equations. So it has got its own built-in functions. For example, in order to compute the rank of the matrix, in order to compute determinant or trace of the matrix, or finding eigenvalues of the matrices, or matrix and vector products, or linear or tensor equations. So these are different types of functions that are available inside the NumPy library, which are located in the linear algebra module. Okay, so consider this particular linear equation. First we will solve this linear equation and see what is the output, okay, or what is the answer for this particular linear equations. So first we can write x1 is equal to 10 minus x2, isn't it? So I'm writing this particular equation as x1 is equal to 10 minus x2. Now consider this equation and we can write it as 2 into x1. What is x1 here? x1 is a 10 minus x2. Okay. And this is 3 into x2 is equal to 27. So we can write it as 20 minus 2x2 plus 3x2 is equal to 27. Okay. Now this can be written as x2 is equal to 27 minus 20. So this will give you result as a 7. x2 is equal to 7. Now you can substitute this result of x2 here. So where you can get x1 is equal to 10 minus 7, value will be 3. So finally we got x1 is equal to 3 and x2 is equal to 7 after solving these linear equations. Okay. Now you can see this particular linear equation. Okay, how can we represent it in the form of two-dimensional array and vectors? Okay, so consider capital A. So we are going to write this in the form of ax is equal to b. Okay, and from here x is equal to a inverse dot b. Okay, so what is capital A here? Capital A will be clearly the coefficients here. So here the coefficient is 1, 1, here it is 2, here it is 3. So this can be written as 1, 1, 2, 3. Now what is x? So x is representing clearly x1 and x2. Okay. And what is b? So RHS side you can see 10 and 27 will be b. Now after understanding what needs to be taken as input and how we can produce the output, so the output will be clearly produced by writing x is equal to a inverse dot b. Okay, so now we can go for implementation part using Python. So first thing you need to import is NumPy module and later import linear algebra module located inside NumPy library. The next step will be you have to represent capital A, right? Capital A is represented as NumPy corresponding array. So the coefficients are 1, 1 and 2, 3, right? And then what is B? So B is represented as 10 and 27, right? So they should be represented like this. And in the next step you have to compute this one, x is equal to A inverse B. So I'm computing A inverse is equal to LA dot. LA is representing NumPy library containing linear algebra module. So linear algebra module dot inverse operation on A. Okay. And then x is equal to A inverse dot B, right? So this is going to be A inverse dot B. Okay. So this is how we can actually do this and look at the program. So I have simply imported the Numpy module, and after that I am importing linear algebra module located inside Numpy, and now assigning capital A corresponding two-dimensional array. Okay, so using numpy.array, which is 1 comma 1 2 comma 3. In the next step I want to initialize b. B is equal to np.array of, okay, so b values are basically 10 27, right? So initialize 10 and then 27. And next compute x equal to a inverse b. So you can see a inverse can be computed first by writing inverse of a, where inverse of a function is accessed from the linear algebra module. Okay, and then x is equal to a inverse dot b, right? So we are accessing with the help of dot function, and finally we are printing the result. So result will be 3 and 7. Okay, the same thing we have obtained while working on it, right? You can see the result that we have obtained while solving the same linear equation. Okay, so x1 is equal to 3 and x2 is equal to 7. The same thing we have obtained after solving these equations in Python. Okay.